So we have a swivel up here so that follows where we're going. Actually, one of the videos that I'll be showing you today involved use of swivel to prepare some pre-lab lecture content. So I'm here on behalf of the chemistry department. We had a number of faculty, both from this university as well as from a couple of our two-year institution counterparts. The courses that we focused our work on is at the 100 level, the Gen Chem series in the laboratories, which is the Chem 121 and 122, and then also Chem 125, which is that new environmental science. Of course, there's also a lab component that goes with that. So we kind of broke up into multiple groups. This has kind of been our mode of operation for the last few years. And so we had a couple of folks, Rick Farr from our department and Shanda Vidmar from PCC, working on finishing up some work with the first Gen Chem lab. And then Sandra Benetti, Matt Cranswick, and Christy Proctor worked on the second semester Gen Chem course. And then David Dillon, Joel Gray, who is from OJC, and myself worked on 125 for the environmental science lab. And so I'm going to kind of go through each of the courses, what some of the focus was on this particular summer. So Chem 121 is where we started our work in the first year of, and I left some X's in there. But all of the labs that are listed here, so there's 10 different lab exercises here. Those have all been developed over the course of the various summer institutes, and they've been refined. These have all been piloted at this point, and revisions have been made, and now they're in the process of getting them into a final format for a new lab manual. But beginning this year, started to transition a little bit to introducing some other content to improve those courses, improve student learning, and that's focused on some of that pre-lab material. Because a lot of times students come into lab and they maybe haven't done all the background research that they should have done, and so now you're trying to catch them up to speed prior to the lab exercise starting, and maybe they're seeing something new for the first time, and we might say, well, everybody's worked with Excel at this point. Well, no, a lot of the students haven't worked with Excel, and in the general chemistry lab, there are computer workstations with a thing called a micro lab set up to it, and they can collect all sorts of information with that and go straight into a spreadsheet, and they can export that straight into Excel, but what do they do with it then? And so you can imagine the instructors going from group to group to group, giving them simple instructions on Excel. So one of the activities this summer was to develop a tutorial for Excel. And it may seem very rudimentary to us, but again, for a lot of these students, this is the first time they've done anything substantial with Excel. So,
hello, my name is Shanda Vidmar.
Volume
and
okay?
this is a video refresher on the basics of Microsoft Excel.
And I'm not
For those
relying
of
on
you
full
who have never
25
used
minutes
Excel,
of the video here
that's
to
what
fill my
this video is
presentation.
entirely.
But what I thought I'd do is kind of skip ahead so you can...
Here again, or maybe I wanted the horizontal lines to be a different thickness. What I'm going to do is I'm going to highlight the boxes that I do want to have the numbers averaged from it. So I've highlighted that, now I'm going to click Enter.
I don't think this was with
as you can see,
Screencast-O-Matic, but I think this was with Camtasia, a competitor's product. But you can imagine, and this will all be bookmarked, so students can say, oh, I need to know how to put an equation into Excel. I can go to
Then I
that
can take
section.
this and I can just copy it.
And we're working on getting that all set up for the students so that we can put it into, with all of the bookmarks, into YouTube, so that we can simply put a link into Blackboard for students to access that. So this is a substantial step forward for us. Shanda has agreed to come to the department, help us further with figuring out all the wonderful things you can do with Camtasia. Chem 122, second semester general chemistry lab. This is an area that lagged a little behind in terms of preparation or revision. And again, we have a whole new curriculum for students. In this summer, there were 3 gaps that remained in terms of the curriculum that we were using some pre-fab labs from publishers to fill the gap. And so the group working on 122 developed 3 new lab exercises to fill those gaps. So why did we go through the process of completely redesigning the laboratory curriculum at the Gen Chem level? Well, I think it's a good exercise every now and again to kind of go back through and ask yourselves what's working, what's not working, how can we better serve our students, not only at the general chemistry level, but how can we better prepare them for moving on to later courses. And so that was part of the reason why we focused on the Gen Chem courses, but also we had made a fundamental change in the way we taught general chemistry. We moved from what most people would refer to as a traditional approach to teaching general chemistry to what they call Adams First approach. And so that created all sorts of chaos in the lab section, because now the lab exercises that we had didn't fit the course content, nor did it fit the style with which the students were learning that content. And so this worked out really well, that about a year after we made that transition, we were able to come in and start making that transition in the laboratory. So this was yours, right, Sandra? So Sandra worked on the colligative properties lab and just took the first material off of the lab handout to show here. And that's these new lab exercises are being piloted this fall. All right, Chem 125 lab. Now, Chem 125 was developed a couple of years ago, both the lecture and the lab. Primarily myself, David Lempel, and David Dillon worked on designing the lecture and the lab. They were piloted last fall, so they're currently in their second rendition. And I had the pleasure of teaching the lecture and the lab for the first time last fall, and certainly found that there were a few things that we can make improvements on in the lab. It's one thing when you're designing an experiment for students to do and picturing how long everything's going to take. And it's a very different thing when those students have the experience of going through that process in the lab. And so you quickly find where we're going to need more time here. We need more instruction here. Or, wow, that was a really big gap of dead time that we could do a better job of utilizing for something else. And so having that experience and bringing my notes to the table, worked with a couple of other colleagues to kind of revamp the lab exercises that are now being utilized, as well as develop a 10th lab exercise, which is a heavy metals analysis for copper in water. So what were some of the things that we did? We identified and rearranged some of the lab exercises to reflect the flow of how things went in the lab, and that maybe meant, for instance, taking, instead of this being soils, nutrients, and pH as it was last year, now we're taking the pH component and moving it up to the previous lab exercise, because students just simply did not have time to do that. But these two lab exercises are tied together anyway. They're working with the same soil samples to determine a variety of properties for those soil samples. For the chemical oxygen demand exercise, the samples have to sit and react in a essentially heater for about 30 minutes, and while we had some questions for students to work on, it simply wasn't enough to occupy that 30 minutes. And so now what we've done is we've added some content, utilizing the fact that the lab that the course is taught in has some computers, so they can get online and they can look at some online resources that relate to the topic of the exercise and fill out or answer a few additional questions. One of the other things that's new for our department is that for the first time we're trying some online exercises. And so when the course was first developed, each of us developed 3 lab exercises, and each one of us had to include one of those as an online exercise. And this went over really well with the students, And it got a lot of very positive feedback on those lab exercises. And it was interesting, near the end of the semester, asked the students, well, all right, we're probably going to develop one more lab exercise to kind of round out what we have. What are your suggestions? What is maybe something we talked about in lecture that you're not seeing in lab? And there were a wide range of feedback, but one of the other questions was, do you think it should be online or in class? And despite all the positive feedback and the fact that they didn't have to show up to lab at lab time, they could do that on their time, they didn't say online. They actually said that they would prefer to be in the lab doing hands-on work, which was a bit surprising to me given all the positive feedback that we had gotten. So over the course of the summer, we revised 5 of the 9 existing lab exercises. There was a new heavy metals lab was developed, and we tested it. It will be piloted with students this summer. With the soils lab, this is one that I have developed prior to this summer and piloted this past fall. There's a lot of new things that students haven't seen before, and a lot of pre-lab lecture involved to get them up to speed. And it just didn't allow for enough time for the students in the lab. So what did is we developed, or I did a pre-lab video, so looking dapper in my lab coat. And again, I won't go through it, this one's only about 8 minutes long. But one of the things that they do is they determine soil texture. And so this is a measure of particle size in soil. And so we use hygrometry, which is one of many ways that one can determine this. So we'll maybe meter graduated cylinder. Let's get to some of the more exciting stuff, some of the hands-on stuff, get the soil in there. Soil suspension, what we're looking at is that the larger particles are going to settle out first, and this is going to affect the specific gravity. So we don't want smaller particles clinging together and falling out of solution. Next, we're going to add enough DI water to get to about 500 milliliters, or fill our graduated. So you can imagine that. You can imagine that if this is just one component of a 2-hour lab, and doing a video here, granted I'm running through the whole start of the process, but at 8.5 or more minutes, that's a substantial portion of the lab time that's occupied just trying to get the students up to speed to be able to do something that they have never done before. And now we can simply direct them to watch this video ahead of time in order to come in prepared to class. All right, so what does the future hold for us in terms of activities that relate to PROPEL and Summer Institute? We are looking at making final revisions now that we will have piloted all of the lab exercises for 122 and 125. Something that we also intend to work on and had hoped to get to, at least in part this summer, was coming up with an instructor's manual for especially the general chemistry labs we have, because that is a very common course that not only all chemistry students are taking, but all biology students are taking as well. It's our largest courses. And so we have a variety of folks that might be teaching those labs from year to year, as well as we have TAs that will frequently teach those lab courses. And so coming up with an instructor's manual and common grading rubric will be quite beneficial. And then looking forward, we have an existing environmental chemistry course, which is taught at the 400 and 500 level, and we'll be developing a lab component to go with that for the very first time. So that is what we worked on this past summer, and what we will likely be looking towards with the upcoming summer. So if there's any questions, I'll be happy to try and address them.
It's not really related, but what does Adams first mean? Does that mean you do physical chemistry?
No, it's actually more of a conceptual approach to teaching chemistry rather than starting off with quantitative measures.
You talk generally before you do balance equations.
Well, we did that anyway, but looking more at the structure of the atom and the properties before maybe looking at, well, again, yeah, quantitative measures. And so I wouldn't say that, and I haven't had the opportunity to teach general chemistry since we've made that move, but it's not really changing the content so much as reorganizing it. And that wasn't well reflected in the laboratory course, and it wasn't easy, we couldn't easily adapt the existing laboratory content to match that.
Is that a national movement?
It is. It has been fairly common. I don't know, and Sandra, you might know what percentage or how popular this has become, but if textbook publishers are any indication, they're all over the place now all of a sudden.
That's the new trend.
Yeah.
And basically what Chad is referring to is in the past, everything was moles and stoichiometry first, and then you would get into atoms and quantum numbers and things like that, and then you would talk about the properties of the different elements. But this is reversing that order.
Other questions?
The online labs,
Yes.
what do you do?
What do you do? Well, it depends on which lab you're looking at. So to give you an example, one of the lab exercises is looking at greenhouse gases, looking at the greenhouse effect, looking at factors that influence the magnitude of the greenhouse effect. And so students are directed to a simulation that CU Boulder has available, and they can change variables and see the impact. And then there's a series of questions in which they are answering. So essentially the laboratory is the computer. The data is coming from the simulation. One of the other ones is population dynamics. So they're looking at available census data online and looking at developing countries versus developed countries versus countries in transition, and looking at how that is reflected in the population distribution.
A quick question regarding that one. What I've seen with my students in engineering is that they do prefer to go online, maybe because of my accent or whatever, but they do prefer that one over being. The last that I do is computer labs, teaching them how to use specific software. So do you have any idea why they prefer to do the hands-on labs versus the online labs? Or
Well,
basically it's
because I think there's a lot to be gained with respect to the other topics that are that's hands-on. That experience of making physical measurements and seeing physical changes occur. So there's no reason, and these exist out there, where somebody can go through the process of maybe making a solution, to take a very simplistic example. And so on the computer you select the pipette and you pipette in a certain amount and you pour in a certain amount of your solvent and you fill it up to the line. Well, while that is perhaps an accurate description of the process that you might go through, actually using the tools to do that yourself, I think is a very different learning experience for the students. Now, we selected topics to use in the online environment that we really couldn't do in the laboratory in any different way. So I could have presented information about population distributions for different countries up on the screen, and we could have talked about it, but they're seeing the exact same thing that they would be seeing on the computer. We couldn't measure photons of light being absorbed versus scattered by molecules in the atmosphere in the laboratory, but they can do that in a simulation to get that information. So I think for us, it had a lot to do with the specific topic, was very relevant to being done in an online environment, and it worked well. And again, students responded extremely favorably to those particular exercises, but I think they also understood the benefit of hands-on activities in the lab for the other students.
What percentage or what was the distribution of students in terms of science versus non-science?
In the laboratory, they were all non-science students. In the lecture, there was one science student and all the rest were non-science. So for many of these students, this is the only science experience that they're going to get at the university. So they're not going to be able to have the same experience in a Gen Chem lab or maybe in a biology lab. And so maybe that has an impact on why they like the hands-on experience too. Yeah.
Just a quick question. Did you, or have you tried to ask the students how they feel about this? I know that's hard to do, but have they said something about we like the physical part of that, and we miss it when we're doing the simulations lab? You know what I mean, like that? Have they said I like one versus the other because we do get the
No, the question was not asked, the why question was not asked. The question was asked with respect to, did you feel that you successfully learned material in an online environment? Did you find that to be a successful learning experience? And then on the final exam, I asked the question of, well, I put in that we are going to be developing another lab exercise. Give us a recommendation. What content would you like to see in the lab? And I think I may have gotten a different answer from every student, so it wasn't necessarily, it certainly put out a lot of good ideas, but then there was the follow-up to that. Would you recommend that the additional lab exercise be online or in lab? And I think with the exception of one student, all of them put in lab. Which again was a bit of a surprise to me. Yeah.
How many of them were in the sustainability minor?
I think there was only one when I taught it. I don't know about the current batch of students. It was a small group of students, and we have to remember that it wasn't in the catalog
Right.
yet. We had tried to communicate the options to our first year advisors and get the word out as much as possible. But in both cases, both the lecture and the lab course are up by about 40% or so over the first year. So I think word is getting out there, and I think that there are, I could ask, I'm not teaching either course this fall, but I'll see if I can't get that information.
And we have 10 students in the intro to sustainability.
That are all
And
in the sustainability.
They're not all in the minor.
Oh,
There's
okay.
about 4, I believe, in your class.
Okay. There we go.
4 or 6. What is your class number now? Is that 15?
The lecture, I think, is a little bit less than that. It was 8 last year, and I think that it's 13 or 14.
Okay.
now.
So, yeah.
And the
you've got-
lab was only 6 students last year, and this year it's 10 or 11.
Right, because that's an optional.
Yeah, so that is a good point. The lab is not required as part of the minor. So in both cases, we had more students taking the lecture than taking the lab, both last year and this year. Of course, it could be time conflict as well.
And this is now a gen ed, right?
It is a gen ed, so it's gone through the GT pathways process and is approved here as well.
Are there any questions? Oh no, this is bad. I'm like losing my mind. I have a resource I want to share with you, and I believe I haven't shared it with